Okay, let's give you guys some more practice. So here, sketch a graph of this function here. Okay, so whenever you get given in a way a fraction here, try to investigate when this whole thing here breaks down. So let's just say it breaks down at, let's just say at 5. So if it breaks down at 5, then investigate what happens just to the right of 5. So it's 5.00001, and then also consider what happens when it's just to the left of 5, 4.999, and so on. Okay, and then also investigate what happens as x tends towards positive infinity, so around this region here, and then also investigate what happens when x heads towards negative infinity. So investigate the two extremes here, and then where it breaks down, investigate the region around where it breaks down. Okay, so anyway, sketch a graph of this function. Press pause and have a go. Okay, so to do this here, here you've got here you've got in a way a fraction here, one thing divided by another thing. When does this whole thing here break down? Well, it breaks down when this thing here equals 0. So the minute you put 0 into this whole thing here, it will break down. So investigate what happens when it's well, hang on. So we are trying to draw our graph here. If you try dead on 0, it breaks down. So investigate what happens when it's just to the right of 0 and just to the left of 0. Okay, so let's look just to the left of 0 in the negative region. If you look at the original function here, the minute you put a negative number into here, then the square root. Well, if you look at the the negative region here is not in the domain of this function here. So already it cuts out the negative numbers here. So you cannot put a negative number into this whole function. It will break down just because this here breaks down. Okay, the minute this breaks down, then the whole thing breaks down. So we know it breaks down dead on 0. Dead on 0, it breaks down. It's pointless investigating what's in the negative realm here. So now let's investigate what happens just to the right of 0. So what happens when it's 0.0000001, just to the right of 0. So let's look at our function here. So just to the right of 0, let's investigate what happens just to the right of 0. So looking at this bit here, just to the right of 0 is going to be a very small number. Okay, very small number. Okay, and then looking at the numerator, what happens when it's just to the right of 0? Just to the right of 0, it would be a very, well, it would be all the way down here, a very big negative number. So I'm going to write it as this: a very big, but it's a negative big number because it's all the way down here. Okay, so looking at our graph here, looking at the graph that we're trying to draw here, just to the right of 0 here, just to the right of 0 here, we will have this situation here. We will have a negative very big number divided by a very small number. Now, so this will be our final answer here. But let's just take the negative out here. Okay, and then concentrate on evaluating what's inside here. So now you've got a very big number divided by a very small number. That will equal a very big number. But don't forget of this minus here, so it would be a very negatively big number, if that makes sense. So really, a very big number here, really, in a way, it is like infinity, and you've got a negative here, so it will head towards negative infinity. Okay, and if you think about it, here a very big number divided by a very small number. Well, even if you have an average number, let's say 7 divided by something that's very small, then overall this whole thing here will be very big. Even if you move to, let's say, 237 divided by very small, then overall the whole thing here would be very big. Okay, the point here is, even if you do have a very big, which is a case in our case, divided by very small, then overall this whole thing would be very big. The point I'm trying to make is that when you have a very big number divided by a very, very small number, it will be a very, very big number. But don't forget we've taken this negative out. So basically overall it will head towards minus, well, it's going to be around minus infinity. So what that means is around around this region here, around around this region here, it's going to be very, very big, but negatively big. So it's going to do something like this. Okay, our graph would do something like this. Okay, and then also when you're trying to draw a when you're trying to draw your function here, try to find the x and y intercept here. In this case, when you have log of x over square root of x, try to find out where it crosses the y-axis or when it crosses the x-axis. Sometimes these are easy to find. In this case, when you make this 0 here, that's when it crosses the x-axis. You see, times both sides by square root of x, so that would be 0. Well, you see, when you put 1 into here, this thing here will be 0. Okay, so what the point I'm trying to make here is that it crosses here. Okay, because looking at this here, when will it equal 0? When the natural log of x is 0. But the thing is, if you put 1 into this thing here, then the natural log of x will equal 0. The point I'm trying to make is that we know so far that our graph would be minus infinity around this region here. Okay, so it would be minus infinity. It will cross here. Okay, and then in the next video we will consider what happens when it's very, very big. Okay, so far we know it's going to be this, and we know it's going to cross this. In the next video we will investigate what happens when it gets very, very big. Okay.